G'day team, welcome back to another video on the applications of calculus. And we're going to start now the process of looking at how the derivative can inform what my function will look like. And we're going to start looking at how the derivative relates to my function in terms of when it's increasing and when it's decreasing. Now we have touched on this in my introduction to differential calculus playlist, but we're going to go over it again and do a more complex example using some of those skills we learned in the differential calculus playlist. So just as a reminder, my function is increasing if my derivative is greater than 0. My function is decreasing if my derivative is less than 0. And it's neither increasing or decreasing if that derivative is equal to 0. So there's 3 conditions we've got there. Now the best way to actually demonstrate this is by doing a sign diagram. So make sure we're labeling our sign diagram with f dash of x, all right, because further down the line we'll be doing f double dash. Now, just as a reminder, these are what we can sort of get our sign diagrams to look like. So A is an intersection of x or where it touches. This is whether my derivative is negative. This is where my derivative is positive. I can have plus and plus or minus and minus. Now, if I do end up finding an asymptote, I do need to put in my dotted line for that asymptote. All right. So just a few little key features there, and we'll keep developing on this in the next video. So let's jump straight into an example. So find the derivative of y equals 3x take 2 over x plus 3 squared, and hence find the intervals where the function is increasing and decreasing. So as soon as you find the intervals where the function is increasing and decreasing, especially if the question in a test or an exam is worth more than a couple marks, we need to go through the whole process. So let's find my derivative first. So I've got 2 functions of x divided by one another. So that means I'm going to have to use my quotient rule. So I need u, which is going to be 3x minus 2. I need u dash, which is the derivative of u, which is just 3. Then I find v, which is x plus 3 squared. And v dash, using the chain rule, is 2 times by x plus 3. Now, applying those things into the quotient rule, I find dy by dx is u dash v, which is 3 times x plus 3 squared, minus, in brackets, 3x take 2, and then 2 times by, we'll go 2 times 2x plus 3, all over x plus 3 all squared. Now, we want to start probably simplifying this before trying to solve where my derivative is equal to 0. And I notice I've got a factor of x plus 3 here, x plus 3 here, and x plus 3 here. So I can cancel one of those terms out. So let's rewrite this in a bit of a simpler way. So I've got 3 times x plus 3 minus, and I'll bring the 2 out the front, 3x take 2, all over x plus 3 to the single power. All right, now that we're rolling with this, we can make it equal to 0. So let's set this to be 0, because that's when I find my sort of maximums and minimums, but it also helps us determine when my derivative or my function stops increasing and decreasing. So when I have a fraction equal to 0, all I need is my top equal to 0. So I'm going to expand this out. 3x plus 9 minus 6x plus 4. Bring together some like terms. Negative 3x plus 13. So minus 13 over here, which equals negative 3x. So x is 13 over 3. All right, beautiful. Now, in my derivative, I also have a denominator. So that means this is my x-intercept. I need to find my asymptote. So that's when x plus 3 equals 0 and x equals negative 3. So I've got an x-intercept at 13 over 3 and a asymptote at negative 3. So let's now draw my little sign diagram. So labeling it f dash of x. All right, so I've got an asymptote at negative 3, and I've got my x-intercept at 13 over 3. Now let's find whether they're increasing or decreasing. So I'm going to substitute in negative 4. Here I'm going to substitute in 0. And now 13 over 3 is bigger than 4, so let's go 5. All right, so now that we've got our sign diagram and our 3 values we want to substitute in, we're going to actually figure out whether they're positive or negative. Now, if I put negative 4 inside of my derivative here, I end up getting negative 25, so that's negative. If I put 0 in, I've got 9 plus 4 is 13 over 9, that's a positive value. And then if I put 5 in there, I've got 3 times 8 minus 2 times 13. So that's a bigger number than that, which will make the top negative and the bottom positive. So that's going to be a negative there. So that means my function is increasing negative 3 less than x, not equal to, because it's an asymptote, less than or equal to 13 over 3. Then it's decreasing when x is less than negative 3, but also when x is greater than or equal to 13 over 3. There we go. Hopefully this has helped you understand sign diagrams, increasing, decreasing functions a little bit better. Thank you for watching, and I'll see you in the next video. Thanks.